process.
Hi everyone, my name is Hasanul Nura Adila.
Hello, my name is Siti Hajar binti Abdul Wahab.
Hi, my name is Arifah Arina.
Hi, my name is Muhammad Aminul Kamil Muhammad.
Hi, my name is Nur Najwa binti Jawhari.
Okay, now we will start on how to construct PERT diagram. PERT diagram must always start with node number 1. Node number 1 basically will start with no immediate predecessors. So, A, B and C activity will start from node number 1. Activity A, duration time is 5. Activity B, duration time is 4. And activity C, duration time is 8. We will go activity by activity. Activity D, the immediate predecessors is A. To start the new activity, we need to end or copy the previous activity with node. So if we want to start activity D, we need to end activity A with a node number 2. Because just now we start with node number 1, so we end activity A with node number 2. And then we can start activity D, duration time 7. After activity D is activity E. The immediate predecessors is B. B is still available, so we end activity B with node number 3 to start activity E, duration time 6. Proceed to the next activity, activity F. Activity F is from immediate predecessors D. D is still available, so we end activity D with node number 4 to start activity F, duration time by 4. After that is activity G. Activity G, immediate predecessors is C. C is still available, so we will end activity C with node number 5 to start activity G, duration time 5. Now we will go to activity H. Activity H from immediate predecessors C, D and E. Except C and D, only activity E is still available. C is ended at node number 5 to start G, while activity D is ended at node number 4 to start activity F. We want to use C and D to restart it again. Therefore, to show the sequence or relationships of the activity, we need to insert dummy. So we will insert dummy from node number 4 and node number 5 to represent C and D and E that's still available. So we will end C, D and E at node number 6 to start activity H, duration time is 6. And the last activity after activity H is activity I. I is from immediate predecessors F, G and H. F, G and H are still available, so we will end activity F, G and H at node number 7 to start activity I, duration time 4. And the last node is node number 8. Number 1 we will consider as the starting node, and number 8 we will consider as the ending node for the diagram. That's all.
So now I will be explaining how to calculate EET and LET for the project. So EET represents the box at the top and LET represents the box at the bottom. EET will be your forward pass and LET will be your backward pass. So we're going to answer this according to the workstation, so you can't jump, let's say here, you can't go from immediately 1, 2, 4, 6. You have to do 1, 2, 3, 4, 5, 6, 7, 8. So we will start with 0. Now 0 plus 5 will be 5. Now we look here because this is the third one. So 0 plus 4 will be 4. Now looking here again, it will be 5 plus 7, so 12. Now we'll look at the number 5, and it will be 0 plus 8, so 8. And now we'll look at number 6. So what happens here in number 6 is that you have the option either to take this number or this number. Keep in mind that for forward pass, you will have to take the bigger number. So you'll take 12. 12 plus 6 will be 18. 18 plus 4 will be 22. So that will be your EET forward pass. So now I will be explaining on how to calculate for LET for the project. So LET, I repeat again, is the backward pass. So to calculate LET, you will start with here. So you have 22 here, it will also be 22. 22 minus 4 will be 18. Now from here, from 7 here, 4, 5, and 6 will be affected by which number you have to choose. So for backward pass, you will take the smallest number for the LET. In order to get the smallest number for the LET, you must subtract with the bigger number of the time weeks. So between 4, 5, and 6, when you subtract 18 with 6, you will get the smaller number. So 18 minus 6 will be 12. And you will also minus 6 for here and here. You will not take 4 and 5. So 18 minus 6 will also be 12 for here. And for here, it will be also 18 minus 6. So 12. Now, from here to here, you will take 12 minus 6 because that is the only option. So 6. Now 12 minus 7 will be 5, again because it is the only option. And 5 minus 5 will be 0. So this is the whole complete PERT diagram in weeks. So if you want to know if your answer is correct, you will always end here with 0 on the top and 0 at the bottom.
Okay, how to calculate project completion time? To calculate project completion time, you need to refer EET and LET at the ending node, which means here 8 is the ending node equal to EET and LET 22, which means project completion time for this question is equal to 22 weeks.
Next, I will explain question D, which is critical activities and critical paths. First, how to choose critical activity and critical path. Critical path and critical activity is where the node has equal EET and LET and total duration time equal to project completion time. The critical activity for this question is A, D, D1, H, and I. Also, the critical path is 1, 2, 4, 6, 7, and 8. It is because based on the project diagram, as we can see, EET and the LET has the equal number such as 0, 0, 5, 5, 12, 12, 12, 12, 18, 18, and 22, 22.
So, how to calculate the total float activity G? First, we must put the formula, and the formula is LET sub H minus EET sub T minus duration. The number of LET sub H is 18 and EET sub T is 8 and the duration is 5. So we must minus all of them and we got 5. For independent float G, same as total float G, but the formula is different. So the formula is EET sub H minus LET sub T minus the duration. Number of EET sub H is 18, LET sub T is 12, and the duration is 5. Minus all of them and we got 1 week. Lastly is free float G. The formula is EET sub H minus EET sub T minus duration. Number of EET sub H is 18, EET sub T is 8, and the duration is 5. Minus all of them and we got 5.
First step, we need to calculate the total float for the particular activity. In this question, they only ask for activity C. So we just need to calculate the total float for activity C. Like this. You can get this from question A when you construct the part diagram. Okay. The first step is we need to calculate the total float for activity C. The formula for total float is LET head minus EET tail minus duration. So LET H is 12, EET T is 0, and duration for C is 8. So we can get total float for 4 weeks. Okay? Okay, the second step is to calculate the amount of delay. To calculate the amount of delay, we can use this formula, delayed time minus total float. So where can we get the delayed time? Okay, the delayed time will mention in this question. Activity C is delayed by 6 weeks. So 6 weeks is the delayed time. So 6 minus 4 total float, which you get from step 1. 6 minus 4 is 2. So we can get 2 weeks for amount of delay. Okay, so the last step is new project completion time. So the formula is project completion time plus with amount of delay time. Project completion time, you can refer from the answer project completion time from question C. Okay, so the project completion time is 22 and the amount of delay time, and you answer the step 2, 2 weeks. So the new project completion time is equal to 24 weeks. So this is how to answer question F. It involves 3 steps. For your information, there are 2 new project completion time. And revise, and one more is delayed. Okay, so how to answer the delayed time? It is quite similar when you answer revised time method, but it is only involve 3 steps. So in this question,
we don't need to calculate maximum time to be completed.